look at that wobble. We have a perfectly straight cam, and yet this still wobbles on the head. That's not gonna work. In fact, we have about 10 thousandths worth of movement here. Welcome to Matt's Automotive Channel. As you just saw in the previous clip, we have some cylinder heads that are pretty severely warped. And that's what we're going to deal with in this video. If you've been following the motor rebuild, you would have also seen in the previous video that the cams had also got warped along with the head. And we were able to straighten those out within a thousandth, so those are good. But we put the cams back into the cylinder head, try to bolt the caps down, too much turning resistance. The head is just too far gone. And these heads have been worked on before, and not in a good way that actually complicates things that I'll show you here in a bit. And so you can straighten the cylinder heads out. I wasn't even aware of this before I started this build. There are basically two different ways to straighten a cylinder head. One is way more invasive than the other, and that's the method that I'm going to use, but modified a little bit. And actually, to be honest, I'm still learning at this point. I don't know if it's going to work, but learn with me, and maybe you can learn from my mistakes if I make some. But yeah, there's basically two methods. One is you bolt the cylinder head down onto a flat surface like this, and then put some bolts in through the head, and tighten the bolts in such a fashion that the cylinder head straightens out. Then you take the cylinder head, put it into an oven, and I think it goes in at 500-600 degrees for 5 to 6 hours. And this is the most invasive procedure because of the valve seats and valve guides. Apparently, in an aluminum head, the aluminum will expand at a different rate than the steel, and then it can cause some problems with that, and then you may be looking at a whole valve job. The other method is to also straighten it out. You could do it on a block like this or on a hydraulic press, and then hit it with a cutting torch. And there's strategic places where you can just very briefly and slightly melt the aluminum with a cutting torch, and that should have the same outcome. So anyway, I'm going to take a little different method. I'll explain as I go through it. But anyway, let me show you the other issue that I have with the cylinder heads, because these things have been to the machine shop before, and they did some things that they probably should not have done. So let me show you. All right, here's the cylinder heads, and I'll just kind of explain here what had happened before. These heads have obviously been warped before, and material has been taken off of these, and I'll show you how I know that in a bit. When these heads got warped before, they took them to a machine shop, and it looks like they just went ahead and shaved this side where the gasket meets up, and then just bolted it back on, totally ignoring the other side of the motor here, which also got warped with the head, but this didn't get straightened, just the bottom part. So let me show you what I'm dealing with. All right, so because the head has previously been warped and taken to the machine shop and resurfaced with ignoring the top part of the cylinder head where the cams reside, the thickness on the edges here is much thinner. This block, brand new, the thickness should be between 5.31 and 5.312 inches thick. I went ahead and measured this block, or I'm sorry, this cylinder head, and what I found was in the center, we had 5.3, which is still down 10 thousandths. So obviously it's been shaved before, but the edges are another 8 thousandths or so. So I got like 18 thousandths here shaved off on the sides. And well, worst case scenario, if we look at the maximum thickness, it could be as much as 30 thousandths of an inch. So, and that's because the thing got warped, and then when they shaved off the bottom side of the head here, they shaved off basically the edges here to bring it back up to where the center was. So the edges here got shaved off more than the center. So the problem is when I bend it back down like that, I'm going to start shaving this off here, probably not so much here on the edges, so we'll make this part thinner again. So anyway, yeah, this is going to be somewhat challenging, and you'll also think that, well, can you even take this much material off a cylinder head? I was told by the machine shop that you can do it because you can have special gaskets made that are thicker, and believe it or not, what they told me was we can have cylinder head gaskets made up to 100 thousandths inches thick. So that leaves us some room to play with. So that's what I'm kind of hoping and betting on, and the reason I'm going ahead to pursue this rather than buying new heads, just simply because I know I've got a lot of material off here, but I think we can make it up with the gasket. All right, this is how I'm gonna go about straightening it. Hopefully this is thick enough. This is an 8" by 1" thickness flat bar that I've had cut to 20 inches, which is the width of the cylinder head. I didn't want any more because I'm gonna be putting this in an oven, and my wife probably won't be happy about that. But anyway, this will fit into my oven in the kitchen. So I know that I'm gonna have to bend the center part down. So my plan is to put some blocks here on the end, and then I drilled a couple holes here, and then I'll bolt down the center part of the cylinder head until I get it straight. Then I'll take this whole assembly and then put it in the oven. I use the head gasket as a template as to where to drill the holes. So I just kind of laid that in there, and this is my template as to where to drill the holes. So now I'll be able to take the cylinder head, sit down here, and it should fit nice and square onto this plate. So let's go ahead and give this a try. Okay, I'm gonna put a couple of blocks here on each side. Now, for these blocks on the side, I'm using something that has a bit of a curved edge because I don't want the block to dig into the bottom of the cylinder head as I apply the pressure. And for this first go around, I don't plan on hitting it with any heat. So what I'm gonna do, even to make it a little better, a little softer, is to place these rags over the ends just to minimize any kind of damage to the bottom side of the head. And I got the heads on here nice and square. And as you can see, I still have all the valve train in here and the lifters and everything. Again, I'm not gonna hit it with heat this first time. I think for this first go around, I'm just gonna see if I can get the head flat. And then if I can, I'm gonna just go ahead and bolt it and see if it holds its shape. I just kind of want to experiment and learn a little bit here about the metallurgy of this and how important that heat actually is. So anyway, I went to the hardware store and I got some 6" bolts here. These are 3/8 inch, and I got a total of 8 washers, 2 bolts, 2 nuts, and I'm gonna use these washers here because again, I don't want to minimize any kind of damage here to the head. So this should be the right length of bolt to do what I'm doing. Let's see how this looks. Just lower that in there, and goes through the head, through the block there, and then I should have just enough here to, and I'll put a couple more washers there, and same thing on the intake side, and then I'll start clamping it down, and then I'll put a flat edge on here and look to see if we are straightening it out at all as we torque the bolt down. Okay, now I did set the cams back down here. I think I'm going to use this for my initial reference to determine if the head's getting near being flat or straight. And as you can see, I still have a fair amount of rocking here, a lot on the exhaust side, and a little bit still here on the intake side. So I'm going to start tightening these down a bit. And actually, I'll set up the dial indicator here first and just check how much rocking I have back and forth. And as I tighten it down, I'll just keep checking and see if that play is going away. I actually have the dial indicator set up here now, and as you can see, I'm rocking this back and forth, and we still have about 10 thousandths, maybe even 11 thousandths of wobble there. So I'm going to start tightening these bolts down now and see if this play starts to go away. Let's go ahead and start tightening this down and see what happens here. All right, I tightened it just a little bit more, and you can see now we're down to about maybe 5 thousandths. So it's definitely going away. So the question is, if I relieve the pressure on this, will it rebound or will it stay? So anyway, let's go down a little bit further until we get down to almost nothing. I'll tighten the intake side here just a little bit. I probably should be checking this at the same time. I definitely don't want to overdo that side. Okay, let's go a little bit more. Okay, now where are we? Maybe about 4 now. I think I'll move it over to the other side and see where we are. Actually, it's pretty similar, about the same. All right, tweak the intake side just a little bit more, and it looks like all that play is gone. So let's go back over to the exhaust side and see where we are. Okay, still got about 5 thousandths there. So let's continue to tighten this side down. I hope I don't go too far on this side. I probably should get the straight edge and the filler gauge out and make sure that I'm not pushing this down too far. Now it's riding on the two ends here, because if it's just right on the two ends and these are lower, I won't be able to detect that the way it's set up here. All right, guys, it looks like the intake side is perfectly flat. I'm dragging here on all of these journals. However, the exhaust side is not perfectly flat yet. I don't know. I may end up loosening the intake side a little bit and then tighten the exhaust side a little bit more. I fear of bending the intake side too much. I do not want this to bend anymore, and I'm afraid it's going to bend a little more when I tighten this exhaust side. So I'm going to loosen this up a little bit and then clamp down a little bit more and then take some more measurements. I'm getting pretty darn close. And I gotta tell you guys, bending this aluminum head is a lot easier than I thought it was gonna be. I did not really have to twist the bolt that hard. And I guess that's why the torque sequence for tightening these down is very important, because it is so easy to bend these heads. And I'm using the straight edge and 1.5 thousandths filler gauge here. And boy, I'm about there. As you can see, I'm dragging pretty much on all of these. The only thing is, if I push down on this edge here, I can get this filler gauge under here. So maybe just another 1/8 turn on this bolt, I think is going to bring me right into spec. And it looks like the intake side here is staying pretty darn flat. So I'm looking out here. So the question is, when I relieve the tension on these bolts, is it going to spring back, or am I going to have to hit it with heat so it stays that way? I am so close right now. Very, very close. And that is not hard to turn. Not at all. And I'm bending the head. Let's see if we're there yet. You know, I try to rock this thing back and forth now, and I don't hear it. I think I can feel it a little bit. Oh wow, look at that. Push down over here. Just barely. We're almost right on. Now I'm hoping I'm not over bending the intake side. Doesn't look like it. It still looks pretty good. Okay, just one more little tiny turn on this and I think we're there. All right, new problem. This bolt is spinning very easy right now, as if almost it is broke or sheared. And the head's not coming down anymore. So I'm gonna pull this bolt out and see what's going on. And, well, there's the problem right there. We're stripping the threads on this bolt. It's just too weak of a bolt. I'm just gonna have to get a higher grade bolt, I guess. So anyway, done for the day until I get new bolt. Looks like the washers are doing a good job of protecting the cylinder head. You can see the impression of the bolt and the washer. And take it off, and then that looks as it did before. Just for info, pulled the bolts out, and looks like we have about 8 to 9 thousandths of wobble again, so it's maybe a little better. The head did flex back somewhat, not all the way, but it did flex back. So this is telling me that, yeah, we're probably going to have to hit it with the heat in order for it to retain its new shape. Okay, I did get some better bolts. Here you can see the cheap ones that I got from Lowe's, and you know, I tried to bolt the head down to this block. It started to bend. It got to a certain point, and then just started to strip out the threads here. So I got some different bolts here. These are a grade 8 bolt. They're a 12 mm by 6 inches. And it did the job just well. And in fact, this plate that I bolted it down to actually bent more than the heads. This is a steel 1 inch thick. It's a flat bar 1 inch by 8 inches, and it was cut to 20 inches, so it's the same width or length rather than as the cylinder head. And I did put a straight edge on here, and this actually bowed upward more than the cylinder head bowed downward. So wow, that's a lot of stress there. So anyway, but that was enough to get the job done, and we got it perfectly straight here now. One other thing I wanted to mention here was the holes that the cylinder head bolts go down into were kind of compressed, and they had squashed down and narrowed the diameter of the hole. And so when I put these 12M ends in, some of them didn't fit. The ones on the end fit okay. And as I moved towards the center here, this one got a little tougher, and then here it wouldn't go at all. So I kind of had to ream these out to get the 12mm bolts in there. But I believe that's the way to go. I mean, they're a thicker bolt, heavier duty, and less likely to strip out, and also a higher grade bolt. But anyway, just to let you know, if you do go with 12mm bolts, they may not fit. You may have to ream these holes out a little bit. There is plenty of room. The stock size of these holes is probably more like 13 mm, because when I put this bolt into the one on the ends, there's actually some wiggle room there. So that's why I didn't feel too bad reaming these center ones out, try to get them back to factory spec. One other thing I wanted to mention is I got 2 washers for each side of the bolt here. I did that and oiled them up really well, so it'd be minimal resistance spinning this. I'd rather have the washer spin against another washer rather than a bolt head spinning against a cylinder head and gouging in and digging in to the head. I definitely didn't want that. And I also did the same thing for the bottom here. You can see I got a couple washers there. And you know, to be honest, these bolts actually spun quite easily. I thought I definitely have to apply more torque than I needed to get this head bent. But if I was guessing, I would say it probably only took about 40 pound-feet to turn these bolts and to keep that head bending. I didn't need a breaker bar, an extension, or anything. It was actually pretty easy to do. Okay, just wanted to show you here. I got the head bolted down to this block here, and I got it all straight. And so before doing any of the heat treatments to it, I just wanted to put the cam caps and the cam back in and make sure that it spins freely. And as you can see here, I torqued all these down to spec. They're all down to 89 inch-pounds. And you can see how easy this turns. No problem whatsoever. It doesn't bind. It spins perfect. So the next step basically is going to be to heat the head up with a cutting torch in some strategic places there. And then hopefully when we unbolt this from the metal block down here, that it will hold form and stay straight. And if it does, the next thing that we're going to do is take the cylinder head back into the machine shop, have the bottom side of the head milled again, because obviously now that it's straight on top, it's now going to be bent on the bottom because it was perfectly straight on the bottom before we bent the cylinder head again. And if this all turns out and works the way as planned, I'm going to do the same thing with the other cylinder head. Okay, I just put the intake cam caps on, and just to see if it still spins freely, and it does, and it doesn't bind in any one position there. So I don't think we even need to straighten this cam out. This one did need the exhaust one needed a fair amount of straightening, but boy, it spins nice now, no problems. The heat treatment worked, and it worked a little too well because we actually overshot. And so I had to set it up a little differently here, where we're now supporting it from the center. And I got some more bolts, and we put those on the end. So now we're going to try to bend it back the other way. So I believe the reason this happened is because once we had it bolted down, the head started to expand. However, it couldn't expand upward anymore. So we got space underneath, so it expanded downward and then ended up going at the other direction. So this time, we're gonna reheat it and just do it in small increments. We'll just barely hit it with some heat here and here, loosen the bolts, and then check to see if the head is any flatter, and just kind of keep doing that until we get there. So we'll kind of just inch our way into it instead of just going full throttle here and doing the whole thing at once. Here you can see the marks where we just slightly melted the aluminum on each side, and we just went on 4 spots on each side, and it just turned out to be a little too much. All right, guys, second attempt. I had this bar here in the middle, got a couple extra bolts, started pulling down on the sides so we could pop the center back up a bit, and what happened was this. Basically just crushed this bar. So the first attempt, we had a bar on each side, and this was strong enough because it was only taking half the pressure. But with the single one in the middle, it was too much, and we started crushing it, and was not able to successfully bend the head back. So I got a flat bar here for aluminum. Obviously, this isn't going to collapse like this thing did. And so I'm going to take it back over to the friend's house, and we're going to give it another shot. The one thing that I didn't mention that I probably should is this crushing here actually occurred while heating the block here, because we were able to, get this under here and then tighten the bolts down until the head was perfectly level, and then we'd hit it with the heat, and then find out that these bolts here got loose in the process. When they I think what happened was the heat got in here, started to expand it, pushed down on this bar, and then as it cooled, it retracted. And so it reduced the tension on the side bolts here, and they were always loose after heating it. And I always thought that was kind of odd, because at the time I didn't realize we were actually crushing this. Got the head back home, took it apart, and found this. So anyway, with this flat piece of aluminum in here, hopefully we'll have more success. Okay, guys, we hit it again with the torch, and we finally got the head to where the cams spin freely. I can spin both these by hand. These are all torqued down to spec, and these turn easily. So anyway, just to let you know, bending it back is way more difficult than the initial bend, getting it to go the other direction. It turned out that we actually ended up having to bend it a little bit too far, and then heated up with the torch, and then it kind of rebounded just a little bit. And so it's within a couple thousandths now of being on spec, and that's good enough to get these to spin freely. They could spin a little freer, but to be honest, I just don't feel like it's worth the investment in time to get it perfect. So anyway, that's where we are at this point, and just to confirm that we got the same issue with the other head. So I'm going to have to go through the same process with this one as I did that one. I'm just going to be a little more careful on that initial bend. So anyway, bending them back is much more difficult, so get it right the first time. This video is getting a little long, and so I think I'll call it quits here. And in the meantime, I'm going to go ahead and take care of the other cylinder head. So now that we've bent them again, the bottoms now are no longer flat. So I'm going to have to take these back to the machine shop and have them resurfaced. So anyway, that's what I'm going to do. And then on the next video, hopefully we can get back onto the block side of things and get the pistons installed, and then go from there. So anyway, I'll catch you on the next one. Have a great day. Bye-bye.